depending on what class you're in and how far we got, we've worked on drawing the Lewis structures of the covalent compounds. And the Lewis structures are just the pictures. It's just, who's sharing these electrons, where are they coming from. So I just want to go through this for you guys so everybody sees this again, how you go about drawing the Lewis structures. And then the activity that you guys are going to do today is now start looking at the molecular shapes, what that looks like for the ball and stick model. And then, like I told you guys the other day, you're going to eventually be doing this with balloons, but I didn't plan on being gone today. So instead, you won't do it with the balloons yet. You're going to do it with the ball and sticks. And then when I'm back, we'll pull the balloons out. So let's just look at NCl3. So I know, first of all, that this is covalent because I have two nonmetals. And so because nitrogen's a nonmetal and chlorine's a nonmetal, I'm going to be able to draw the Lewis structures. So I look at valence electrons, and nitrogen's in family 15, so he has 5 valence electrons. And chlorine's in family 17, so he has 7, but that's happening 3 times, so there's 21. So I have a grand total of 26 electrons. I'm going to divide that by 2, and I've got 13 pairs of electrons that I'm dealing with. So let's talk again what we're doing. You're looking at valence electrons, not total electrons, just the valence electrons, because that's all we really care about, okay? So we figured them up, added them all up. So the least electronegative is going to go in the center, unless it's hydrogen. So nitrogen's further to the left on the table than chlorine, so he's going to go in the center, and you're going to have 3 chlorine go around the outside. Okay, I got 13 pairs, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 1 pair left over. Now I go to the central atom. So notice you give everybody on the outside a bond first, then start filling the lone pairs, and then anything that left over goes to the central atom. So let's do a quick check to see. We've got 2, 4, 6, and 8. This chlorine's good. 2, 4, 6, and 8. He's good. 2, 4, 6, 8. That one's good. 2, 4, 6, and 8. The nitrogen's good. So actually, to be correct when we draw this, it would look like this, because this lone pair right here on the nitrogen is going to shove these bonded pairs down. Okay, so this is your Lewis structure. This is what you're going to draw. So what you guys are going to do today is you guys are going to be doing this activity. So it gives you the information about the background on what's called VSEPR. And VSEPR just means valence shell electron pair repulsion. So if you think about that, okay, valence shell. So it's the electrons in their outer energy level or their outer shells, like the s orbitals, p orbitals. Electron pair repulsion. Because these are electrons and they're the same charge, they're going to repel. So that's what VSEPR means. It's just the outer electrons and how they're going to pair up and how they're going to repel. So this gives you some background. You're going to read this on your own or read it with your pod. It'll tell you what to do, gives you the idea what the colors are in the ball and stick models, okay? And then this gives you the shapes. So let's take a look. You've got, and you can also look at page 260 in your book if you want to. So that's another reference as well, and I'll write that down here. You can go to page 260. So what I'm going to look at is I'm going to look at a structure where I had a lone pair on top and 3 bonded pairs coming off the bottom. So I'm going to take a look. All right, I got 3 bonded pairs coming around, possibly, or let's look at this one. You've got a lone pair and then 3 bonded pairs coming down to the side. This is going to be an example of trigonal pyramidal because you've got that lone pair that then is going to push them down. So you want to make sure and look to see if there's lone pairs anywhere, what's exactly going on. This is an example of trigonal pyramidal, okay? So how you guys do your assignment is you're going to count up your total of valence electrons. You can give me pairs if you want to. You're going to draw your picture. You're going to take a picture of the actual 3D model when you build it, and then you're going to give the name of the shape. That's it for now. We're not talking angles. We're not talking polarity. We're not talking hybrids. Some of you guys heard me say that. Gen Chem, you don't have to worry about the hybrids, so ignore I just said that. But we're literally just introducing into, can you find your valence electrons? Can you draw the picture? Can you represent it with a model? And now can we start seeing what shape these guys make, okay? So for your guys' assignment, what you're going to do, you can draw these pictures in your individual notes if you want, and then I will just have to see those or get a picture of them. The 3D model, though, you can take a picture of it with your computer and insert it right into here. And so you don't have to everybody take a picture of it. You can take a picture, one person's computer, and then you guys can airdrop onto each other's computers if you want. Do it as a pod. Don't do it as an entire class and get done with this, because you really want to go through each one of these. You don't want to do one and then say somebody else do my own. So make sure that you are working through each one of them. But instead of everybody taking a picture, one person in your pod can take a picture with your computer and just share it with everyone in the group, or share this document with everyone. Okay, so that's how you're going to do this. So you're going to count up your valence electrons, give me your picture. Like I said, this could actually be in your notes. You don't have to put it here. And then this would be an actual legitimate picture of the model that you guys build. And then this is going to be the name that you think that shape's going to make. Okay, so that's what you guys are going to do tomorrow. Don't forget there's an actual another page to it. This one down here, the CO3 -2, I'm leaving as a challenge. I want to see what you guys think this would mean. The only thing I want to say to you is, remember, if it says -2, that anion is going to require 2 electrons to be pulled in. You might want to think about what that does for your total number of electrons. If it's a -2, like what's that going to do to how many electrons you would have? One other thing I want to show you guys is a situation with what we call resonance structures. So I'm going to erase this. Okay. And let's do a situation where we could have a resonance structure. Okay. We'll go like this. All right, so sulfur has 6. Oxygen has 6 times 3, so there's 18. You got 24 electrons, which is 12 pairs. Sulfur is less electronegative, so it goes in the center. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so I got rid of all my electrons. All the oxygens on the outside look good, but my sulfur doesn't look good. So when you've done everything you can and the central atom isn't good, is when we're going to start bringing in the double or triple bonds. So these lone pairs right here come in as a double bond. You didn't change the amount of electrons, you just pulled them over to say, hey, I'm going to have to share a little bit more here. That's it. Forms a double bond. But that double bond didn't have to be here. It could have been here, and it could have been here. So here's how you draw this. And like I said, it's called a resonance structure. The resonance structures are when you have multiple possibilities for where double or triple bonds could be. So you could individually draw a picture for every one of them, or you can do this. Everybody gets a bond, but there's a possible double bond right there, a possible one right there, a possible one right there, and then you'd finish up with your electrons. So here's what these dashed lines mean. If these dashed lines right here was an actual double bond, then this dash would be the 2 lone pairs. This would be the 2 lone pairs. If this is the actual double bond, then these guys go over to be the lone pairs. So instead of drawing every example where that double bond could be, the dashes represent that the resonance structure could show the double bond here, it could show it here, or it could show it here. So you might run into a couple of those on that document. Last thing I want to say to you guys is, let's say I give you this. Okay, OF6. And you're asking yourself, only 8 things could be around the central atom, but if everybody's a pair, I already know that's going to be 2, 4, 6, 8, 10, and 12. Okay. Right now, instead of figuring out who the exceptions are, if I give you a formula and I say draw it, you just do what you're told. There are things that are called expanded octets. And so what we're going to do is we come back and look at this document. We're going to look at which ones did you find will actually expand their octet, meaning they can hold more than 8. Remember, octet means 8. So instead of you trying to worry about, why did this one do this? Did this one do it? I don't know when to do it. Don't worry about it. If I give you a formula that gives you more than 8 electrons around the central atom, just do it. And then from there, we'll be able to come back and notice which substances do that and possibly why they do it. So don't overthink it right now. Just trust me and go with it if I gave it to you. Okay, so I'll say again one more time what you guys are doing for tomorrow. Get through as much of this as you can. I do not expect that you're going to get through this whole thing, but I expect you get through quite a bit of it. So you're going to look at your document, you're going to count up your valence electrons, draw your picture, can totally be in your notes, does not have to be on here. You can do it on a whiteboard and take pictures if you want, that's your call, or if you want to write on my tables with the chalk, you can do it. Please just erase it for the next class. You're going to build the model with the actual ball and stick models. Please make sure all those get put back. Also, don't shove the sticks down into the balls or we can't get them back out. And then you're going to give the name of the shape. Get through as much of this as you can so that hopefully my goal is to be back on Thursday, hopefully fever-free in our home, and I'll be back. Then we'll go further with this. We'll talk about the angles, we'll talk about what's going on, and we'll start building with the balloons. And so that's your goal for tomorrow. Get it through as much of this as you can. If you have questions, please ask. Don't forget to do the videos that I had emailed out for you today. If you have questions on anything, please send me a message. I'll be able to respond. I just don't know how quickly I'll get to you guys tomorrow. All right, have a good day.